Welcome to today's Explainer. We're diving right into a masterclass on the life cycle and, quite frankly, the devastating impacts of particulate air pollution. I am absolutely thrilled to guide you through this material today. We're going to break down the science step by step, looking at exactly how these pollutants travel through our environment. Here's our roadmap for today. We'll start with Part 1, the origins of pollution. Part 2, nature's cleanup crew, our environmental sinks. Then Part 3 covers physical impacts and visibility. Part 4 explores corrosive effects on materials. Part 5 tackles biological threats to life. And we'll wrap it all up in Part 6 with a summary and some final thoughts. All right, let's dive into Section 1, the origins of pollution. Let's look at how human activity creates particulate matter to understand exactly where this pollution comes from. Now, academically speaking, we classify these starting points as anthropogenic sources. Basically, this means they originate exclusively from human activity. So no, we're not talking about a random volcanic eruption here. Anthropo means human and genic means origin. It's an absolutely crucial distinction because it highlights the variables that we actually have the power to control. So what does this look like in the real world? Well, they're everywhere. We're talking massive thermal power plants, heavy industries, smelters processing metals, and intense mining operations. But it also scales all the way down to everyday activities, agriculture, construction, deforestation, and, yeah, even the automobile exhaust from your morning commute. Every single one of these activities is just constantly pumping particulates straight into our atmosphere. Which brings us to Section 2, nature's cleanup, environmental sinks. Let's explore how the environment actually attempts to process all those pollutants once they're airborne. Think of a sink as nature's built-in filtration system. It's simply a specific place or a method where pollutants are actively pulled out of a given environment, whether that's the air, the water, or the land. And this environmental removal process is pretty fascinating. It generally happens through dry or wet deposits. Sometimes, gravity just does the heavy lifting, literally pulling heavier particles right out of the sky. Other times, these particulates are washed out entirely by precipitation, like when a heavy rainstorm suddenly leaves the air feeling crisp and clear. Here's where the chemistry gets really interesting. Take a particle like soot. When it meets a sink, it can be absorbed, with a B, meaning it's taken completely into a host material, soaking in like water into a sponge. Or it can be adsorbed with a D, meaning it just attaches right onto the surface of the material. It's a subtle but totally vital chemical distinction in how our world processes this mess. But what happens when nature's sinks get completely overwhelmed? Let's move to Section 3, physical impacts and visibility, and look at the visible consequences. The absolute most immediate physical effect, and one you've probably experienced firsthand, is the scattering of light. When suspended particles interact with sunlight, they scatter it in different directions, causing a massive direct reduction in visibility. This is the exact mechanism behind that thick, hazy smog we so often see blanketing our cities. And look at the microscopic scale of the threat here, just 0.38 to 0.76 micrometers. Particles in this tiny range are literally the most effective at scattering light and blinding our skies. They are perfectly sized to interrupt the wavelengths of visible light. It's wild. But the damage goes way beyond what we can just see in the air. Let's look at Section 4, corrosive effects on materials, specifically how pollution destroys buildings and metals. Because these microscopic pollutants don't just float around forever. As they settle, they aggressively soil the surfaces of the buildings we live and work in. Even worse, they actively corrode metals. And get this, that corrosion is triggered specifically the second relative humidity climbs above 75%. The moisture in the air literally acts as a catalyst for destruction. And this gets incredibly severe when you introduce low pH-producing gases. We're talking sulfur oxides, nitrogen oxides, and carbon dioxide. When these acidic gases mix with high humidity and particulate matter, bam, you've got a highly corrosive environment that is just slowly, relentlessly eating away at our infrastructure. Now, moving from structural materials to living organisms. Section 5, biological threats to life, the devastating effects on plants and human health. Let's start with plant life. Airborne particulates don't just reduce vital photosynthesis, they cause what we call lysis of the leaves. Lysis is the literal biological breakdown and destruction of the plant's cellular walls, which leads directly to leaf death. It is choking the plant at a cellular level. For us humans, the threat is just as severe.
The absolutely crucial point here is that fine particles measuring less than 3 micrometers in size are small enough to easily bypass our upper respiratory defenses. They travel deep into our systems, directly irritating the lungs and frequently triggering asthmatic attacks.
And specific biological threats lead directly to specific severe diseases. General airborne substances act as aeroallergens, causing allergies. Inhaling asbestos directly causes asbestosis. Silica exposure leads to silicosis. Inhaling metal oxides results in metallic poisoning. And agricultural sprays expose us to highly toxic insecticides and pesticides. The link between the anthropogenic source and human illness is direct and it's undeniable.
All right, let's wrap this up in Section 6, Summary and Final Thoughts, so we can fully grasp the big picture of this cycle and how to stop the damage.
So, we've successfully traced the entire life cycle of this pollution. Step 1, it's born from human-made, anthropogenic sources. Step 2, it completely overwhelms nature's environmental sinks. Step 3, it causes physical and material degradation, blinding our skies and corroding our buildings. And finally, Step 4, it penetrates living cells, causing severe biological disease in both plants and humans. I'm going to leave you with a final, provocative thought to consider today. If these microscopic particles, especially those under 3 micrometers, can so easily bypass our body's natural sinks and defenses, how must we re-engineer our industries to stop them before they are ever even born? Understanding this cycle isn't just academic, folks. It's step 1 in solving the problem at its source. Thank you for joining me for this explainer, and keep questioning the world around you.